for section 2.7, now this time we focus on the metal oxide. Well, they will decompose into metal and oxygen during the electrolysis. So the electrolysis is the main point. We must use electrical energy to break down them, or else there will be no reaction. And don't forget, there should be in molten state. Okay, so this is suitable for those extremely reactive metal, that is from potassium to aluminium. Okay, so for sodium, well, easy, it will become sodium and oxygen. Both of them are element, right? And aluminium will form aluminium and oxygen. Well, the equation is easy, but how about the chemical reaction or chemical equation? Now, first, of course, you should able to write down the correct formula for sodium oxide and aluminium oxide. Okay? Now, if you forget it, that will give you some hints. Well, the sodium ion is positive 1 charge. The aluminium is 3 plus in charge. So the oxide is 2 minus charge. Okay, so after they break down, so of course oxygen should appear as O2. Well, in this case, that's why we need 2 for sodium oxide in order to balance the number of O. And finally, we got 4 sodium metal. Okay, well, for aluminium, more or less the same. What we get is O2 and aluminium. Okay, but same, we need to balance the number of oxygen in both sides. However, we got 3 oxygen in the left hand side and 2 oxygen on the right hand side. So we should multiply the oxide by, it should be by 2. And hence we got 3 O2, okay, and 4 aluminium metal. Okay, now, so you should be careful. It should be 4 aluminium. Okay, this is correct, and never write something like this. Okay, but this is not correct, because only molecule will do it like this. Okay, and how about those metal compound, which is chloride? Okay, so again, molten state is necessary. Okay, and again, this is from potassium to aluminium. So let's see, potassium chloride will become potassium and chlorine. Okay, so be careful, the spelling we change it. Okay, and aluminium chloride will become aluminium and chlorine. Okay, well, next we need to balance the equation. It's KCl and AlCl3. Okay, but because chlorine is a diatomic molecule, just like oxygen, okay, O2, N2, whatever, okay, this time is Cl2 and Cl2. So we should do something to balance. Okay, and here we need 2 KCl, and the result is we got 2 potassium and 1 chlorine molecule. For the aluminium chloride, the case is similar. Okay, we multiply the aluminium chloride by 2, and hence we got 3 chlorine molecule and 2 aluminium metal. Okay, so this is how we extract those extremely reactive metal by electrolysis the molten ore. Okay, well, next we will try to discuss how the metal behave. Okay, now a very simple idea is, okay, for metal reaction, you can always remember the metal will lose electron to form metal ion. Well, this is something I say this is always true. Okay, this is always true. So let's see. The first one is metal react with oxygen to form metal oxide. Well, this will undergo start from potassium up to mercury or silver. Okay, it's up to you. So let's see. Sodium react with oxygen, easy. Sodium oxide. With similar idea, we got calcium oxide and aluminium oxide. Okay, this is easy to handle. Okay. Well, next is try to write down the chemical equations. Okay, this is sodium, is calcium, is aluminium, and I'm sure you understand oxygen should be exist as O2, right? How about the product? Sodium oxide is Na2O, calcium oxide CaO, aluminium oxide Al2O3. Okay, very good. But how to balance? Okay, let's start with the first one. On the left hand side, we got 2 oxygen, so we should have 2 sodium oxide, right? And the result is we need 4 sodium, like this. Okay. Next, we have 2 oxygen on the left hand side, so 2 calcium oxide on the right hand side, and 2 calcium here. Okay. Well, finally, it's a bit tricky because we got 3 oxygen on the right hand side, so we should multiply by 2 and here by 3. Okay, in order to balance the number of oxygen in both sides, and the result is we need 4 aluminium for our reaction, like this. Okay, so this is the first reaction to form metal oxide. Well, next one is how about they react with liquid water? Well, only those extremely reactive metal can react with liquid water. So it starts from potassium to calcium, where we have only 3 choice. Okay, only 3 choice. So the potassium react with water to form potassium hydroxide and hydrogen. Or similarly, this is calcium hydroxide and hydrogen. Okay. Well, next we try to write down the chemical first. This is K. This is H2O liquid for clarify. Okay, and this is KOH. Well, this is because hydroxide ion is -1 and potassium ion is +1. Okay, and don't forget is H2. Similarly, this is Ca and H2O liquid to form calcium hydroxide. Okay, and H2. Okay. Well, next we need to do something to balance. This is a bit difficult, so please pay attention. For the potassium case, hydrogen on the left hand side is an even number. Okay, an even number, H2O, so this is an even number. So we should first multiply this one in order to make the hydrogen number on the right hand side is an even number too. Okay. Okay, next we consider there should be 2 oxygen on the right hand side, so we need 2 water on the left hand side. It looks nice. Okay, finally the hydrogen number balanced, the oxygen number balanced. Finally, we need to balance the number of K. This is 2. Okay, very good. Okay. Well, next one is calcium. Okay, so on the right hand side we have 2 oxygen, 2 hydro. Okay, 4 hydrogen. So easy. This is 2 water can finish the job, right? That this is the case when we react with liquid water. So how about react with steam? Now react with steam, this time we got metal oxide. Okay, oxide. They start with potassium up to where? Okay, up to, it should be iron. So the case is zinc. They will form zinc oxide and hydrogen. And magnesium, this is magnesium oxide and hydrogen. Okay, so write down, this is zinc, this is H2O, this is gas, magnesium, and this is H2O gas. Result is zinc oxide, magnesium oxide, and H2 and H2. Well, easy, because both of them got 2+ in charge for the metal ion. Okay, so you can see we have finished the job. Okay, and finally the metal react with acid. So this happens, okay, theoretically this is from K to lead, but as we know, we should not try this with potassium or sodium, which is too dangerous. And first, you should able to write down the formula and corresponding anion of the acid. Okay, so let's fill in. And how about their corresponding anion? Oops, sorry. Here shows. Okay, so let's write down. Calcium react with hydrochloric acid. That is calcium chloride. Okay, and hydrogen. The second one is magnesium sulfate and hydrogen. The third one is aluminium ethanoate. Okay, now, so it is easy for you to understand. The acid should be ended with IC, right? So during the process, the IC will be cancelled out and become ATE. So for example, sulfuric acid becomes sulfate and nitrate acid becomes nitrate. Okay? And finally, this is, okay, according to the hints, it should be iron, don't forget the free, iron-free nitrate and hydrogen. Okay? So next, let's write down, this is Ca, this is HCl to form CaCl2 and H2. So if you can write down the correct formula, so you have done over 90% of the job. Okay, so magnesium is magnesium and sulfuric acid. This is aluminium and ethanoic acid, and finally is iron and nitrate acid. Okay, to form, let's write down, it's MgSO4. This is Al bracket CH3COO, free, and this is iron-free nitrate. This is Fe bracket NO3 free, and hydrogen. Okay. Oh, okay. Because here, let's give you some hints. P plus and NO3 minus. Okay. So again, this is aluminium ion and ethanoate ion. So the result is like this. Okay. So hope you can understand. Well, next one is try to write down the correct coefficients. Okay, for calcium it's easy because we got 2 chloride on the right hand side, so 2 is enough. Okay, and magnesium is even simpler. Okay, so how about ethanoate? Okay, now ethanoate is a bit difficult because on the right hand side we got 3, so should I write 3 here? Okay, if I write 3 here, then the hydrogen amount will be something like this. It doesn't look good. Okay, even though I'm correct, but it doesn't look good because in DSE, okay, you are not allowed to write fraction as a coefficient. Okay, so we should multiply the whole equation by 2. Okay, so this one become 2, is 2, and this one, oops, this one become 6, and finally, okay, this one become 3. Now it looks good now. Okay, and a similar case, okay, for this one. Okay, first, should we write down something like this? This is 3 and this is 3.5. Okay, then multiply the whole equation by 2 is, oops, this is 6. Oops, what's that? 6, and this is 2, and finally this is 3. Okay, so we finished this exercise. Okay, so hope you can do it on your own, and don't forget to do revision. Okay, we do it twice, third time, fourth time until you are familiar with that. Okay, see you.